Okay, Assalamualaikum. I'm Fatih Nur Shazwina binti Suhairi. I will be recording my screening air dissipation model for assignment. For my assignment. So let me start right now. First, I have assignment that be assigned to me. Is for part A and part B, or question 1 or question 2. So we go for the question 1 2. So I can screen you. So let me save first the screen view first. Okay, now we want to choose the source type, dissipation coefficient, and Fleckborg receptor. Okay, for my assignment, the source type is that we've been assigned to me is that means I choose the point, and for dissipation coefficient, I choose the rural type because it might be that this assignment is being located in the rural region. And for the flagpole receptor, we took the 0 because it doesn't say it doesn't say in assignment what the receptor height above ground. So for the emission rate, uh, it costs 550, and for stage height is 0.7, and for the stack inside diameter is 4.59 meter, and stack gas exit velocity is 12 ms, and stack gas exit temperature is 478 Kelvin. For the ambient air temperature, its default is 293, but for my assignment, it's cost 291 Kelvin. Sorry. So, next, okay, let's pick the next. Okay. Okay, after that, we choose the terrain option. So I choose the simple terrain, and the simple terrain that I choose, I choose the flat terrain. And for the choose at least one option, so for the question 1, I choose the automatic distance. And for this option, fumigation and burden wash, I don't choose it because it doesn't say in the question 1. So for the meteorology, for simple terrain screening, I choose full meteorology, all stability classes, and wind speed. So and next, for the complex terrain, we don't use it, so just ignore that. For the automatic distance, okay, for automatic distance, for mean distance, I choose 1 meter. And for this question 1, it's been state 3,500 meter for the max distance. And for discrete distance, I don't take that, so I just use automated distance. And for the wash, I just do this, and I don't take, and fumigation is not true. So let's continue. We take Next. So my project is complete, so we can run now. We can run the this file now. Okay, now run is finished successfully. So this means that I've been successfully doing my question one. So for the graph, we can see that for this comment, um, the peaks contraction at this downwind distance for 3,500 distance. So for the peaks contraction, I got 600. Uh, I got 600 uh, gm for the concentration, for the peaks concentration. So the graph is started with the um, down below first, and then it straight up and got to the 600 concentration, and then it's uh, it's coming down after that. So this means that, and it stopped at the 300 gm. Okay, and for the output, for the output, we can see that it's been running here, that for the simple Terran import, and it is seeing like that. So this is my output file. Okay, okay, that's for my question one. So we move to the question two. Okay, for question two, I use the same part as question one, but I only add the option. Okay, for the option, I just add a building dot downwash, because in the question two, I have to differentiate how the CO2 concentration is different if that we have the building the wash in near the concentration. So I just take the building the wash, and the other option is still same, but I only add the building the wash. For the building the wash, okay, for the building height, I use 500 meter, and the mean horizontal building dimension, I choose 200. I choose 100 and 150, and for the max horizontal building dimension for B, I choose 200. So for the Kalman sculpture, for the Kalman sculpture algorithm, non-regularity option for this center line, or we call this for the this thing. So I just put the uh, 10 or okay, I choose 100, I choose 90. And for this, for these things, for this part, I take 40, and print construction detail I also take out. And then for the fumigation, I don't take that, so just make a note that. So we be next. Okay, for this project, as for question one, for question two, also I been complete. So we can also I can run the this file. Okay, for for this question 2 also run finish successfully. So we can see the graph. Okay, and this graph is a little bit is different from the graph one at the question one, because um and this graph is show the one line, but it's not like a ground line, so it just been straight, but it's after that it's down after that. So for the peaks concentration for this graph, okay, I got 4,000 and above, and it started down and stop it at the 1,000 concentration. 1,000 concentration and for this graph. So we can see that the contraction maximum is got 4,000 concentration, and it's also the peaks concentration for the peaks concentration is also 4,000. Okay, so now we move to the output file that I got. Okay, this is my output file for the question 2. So we can see that the simple table input that I've been insert is same like the question 1, but I just add the building down wash. Okay, this is my output file. Okay, okay, this for the conclusion in my video this. Okay, for my conclusion, between question 1 and question 2, we can see that the graph is usually different, uh, and the concentration and for the peak concentration is also different. For the question 1, we got different value from the question 1, and question 2 is also got the different value too. So it mean the building don't wash is make the effect for the SO2 concentration. So this thing prove that the SO2 concentration is also different if just we add the building don't wash at the region. So that's all from me. Thank you for watching. uh, Thank you.